Sudoku degenerates, welcome. This is, oh yes, thank you for the crab rave. Hi, LM Damasi, Isaiah, AQ. Oh yes, let me... let me ping the setter of this puzzle. Alright, I got 2 first puzzles in the queue today. I got, for one thing, we got Greg's first cage Sudoku by a new setter. Alright. Standard killer rules. Alright, normal Sudoku rules apply, so every row, column, and 3x3 box, I gotta put the digits 1 to 9 once each. And digits in cages must sum to the number in the top left corner. So these must sum to 12, these 3 must sum to 14, these 2 must sum to 13, these must sum to 35, and cannot repeat. So these must all be different, and these must all be different. Alright, that's all the rules. Well, the gimme is there. 30, there's only one way to make 30 in 4 cells, and only one way to make 35 in 5, okay, so that's 3 or 4 up here. Ah, and this is also only 3 or 4. In fact, this can only be 4. With the 9 here, 3 here. Okay, this isn't 2, 4, so it's 1, 5. That also rules 5 out of here. This is 5, 7, 8, 9. Oh, 12 in 3 cells without using a 1, 2. There's only one way to do that. Okay, so there's a 5 in here and a 5 up here. This is not, this 10 cage is not 4, 6, or 1, 9. So it's 2, 8, or 3, 7. Oh. Where does 1 go in this column? It can only go up here. Where did... Oh. Oh. This can't have 3, 4, or 5. Oh, and the only other option is 1, 6, 7. So that's 6, 7... that's not 6 or 7. That leaves 2, 8, and 9. This is not 9. 2, 8, 9. Aha, this can't be 8 or 9. Because 12 and 3 cells... Oh, it must have a 1 and 2 in it, and that's the only place for a 1. And this is either 3, 6, or 4, 5. Oh, this isn't 4, 5, because this 3, 4, 5 pair. In fact, it can only be 6. Oh, this is not 2 or 3 now. So that's not 7 or 8. Oh, where does 1 go in this box? This rules it out of here, these rule it out of here, and the cage totals rule it out of the cages. Oh, 5, 7, 8, 9. There's no 7 down here. That's 7. Oh, in fact, isn't this a naked single? Yeah, that's 4. There's a 3 down here. What's left up here? There's a... Oh. 2 and 4 in this box, they go down here. So that's, leaves 5 and 6. Where did... Oh. 1 in this box only goes here. Alright, what does... This isn't 2, 5, so it's 1, 6, or 3, 4. That's not 1, that's not 6. Alright, 17 plus 9, that's 26. That's almost exactly the average of 5 cells. So that is... Oh, where does 7 go in this box? Aha! 5, 6, 8 rules 6 and 8 out of here. Okay, that's 6. Okay, so 7 in this cage goes up here. Am I missing any more obvious... I don't think so, although... This digit in this box has to go down here, so this is 368, also just by Sudoku, it's 368. This is, oh, this is 2 or 4 to finish the column, and it can't be 2, that is 4. Where's, okay, 4. I had to find the 4 on my keyboard. That's 4, that's 9, aha. Aha. That is... Okay, what is that? Oh. This 14 cage needs a 1, doesn't it? Because it can't have 2, 3, 4, 5. Because 3 of those would have to go here. Also, that would rule too many low digits out of here. That just means one of these is a 1. Okay, so that doesn't... Oh, I've got 1, 8, and 4, 5 ruled out of here. That's not 2, so that's not 7, or 3, 6. Does that... Oh, that doesn't break anything yet. So I know this has a 1. And I know it only has 1 of 2 or 3. So these are only 1 of 2, 3, or 4. Right, so it's 1, 2, 5, 6. Aha. Oh. That's not 6, so that's not 3. That is also not 3. Oh, where does 3 go in this box? And in this box? What's left in this column? 8 and 9? Resolved. And that is 4. Two, 3, 7. 2, 4, 5. Oh. 4 in this box is forced. Alright. This cannot have a 1 or a 4. Is there anything else it can't have? A 6. So it's 2, 7, 8, or 3, 5, 9. So it has a 7 or 9, and that goes up here. And these are from 2, 3, 5, and 8. As evidenced by this. Alright. Oh. Here's something simpler. What's left in this column? 7. Okay, that's 7, 8. That's also 7, 8, 9, and this column goes here. What about this row? 4, or 9? One, 2, 4, 1, 2, 4, and 8. This is 2, 4 resolved. Okay, this is a 1, 8 pair resolved by that. And that is 7. That is 8. Okay, that's 8 in that box. Is that all the 8s? Almost. Got a little X-wing to finish those off. Alright, what's left down here? 5 and 8. Oh, this can't have an 8 in it either. So it's 3, 5, 9. This is 3, 5. This is 9. This is 2, 7, 3. That's 2, which makes that 7, 5, 2, 4. 4. I meant to click that first. 3, 4, 8, 7. 5, 8, 5, 3, and, 6, 5, and the last digit, 6. All right. Yeah, it was neat. Thank you for the GGs. I recall what Skojo said in, every cage felt purposeful, like it was here for a reason, and yeah. Yeah, it was neat. Alright. Next up is... Thank you for the, crab raves. Let's see, pin this. Alright, I pinged Tonberry Java. Love the username, by the way. Okay, so it's Sandwich and Killer. Okay. So, every row, column, and box, I gotta put 1 to 9, and also gotta put... all cages contain non-repeating digits that sum to 15. So these sum to 15, these sum to 15. Okay, I see where this is going. So do these, and clues outside the grid are the sum of all the digits between the 1 and 9 in that column or row. So for instance, in this row, if I put 1 here and 9 here, that means that these sum to 15. Alright, yeah, that's all the rules. Well, for starters, there's only one way to make 15 in 5 distinct cells, and only 2 ways to make it in 2. But the 1 and 9 have to go next to each other in this row because of this 0 clue. So we get 2 right away. Oh, and that also resolves this, leaving a 7-8 pair over here. Oh, welcome in. Ah, right, and this 35 means the 1 and 9 have to be on opposite ends of the row, because the sum of all digits in a Sudoku column is 45, and that minus 10, which is the sandwich crust, is 35. So every cell in here has to be part of the sandwich. And now, yes, that 10 plus 15 plus 15 is exactly 40. You can choose which one you want. Just hit exclamation point avatar and, okay, and these sum to 10. Oh, this is also... Oh, this isn't a 7-8 pair, so it's another 6-9 pair. Nice. Ah, and the 0 clue means the 1. This is here. These two 15 cages mean... Oh, this is interesting. This 3 sandwich clue, I don't think I can put a 1 here, because it's going to have to go 3, 9, which breaks this, or 3, 9, which there isn't room for. Alright. No, okay. Ah. 6, 7, 8, that adds to 21. Plus 15, that's 36. So these add to 9. Oh, 9, and it's not 3, 6, 2, 7, or 1, 8, because those digits are used up here. So this has to be 4, 5. Oh, no worries. Oh, I should also do the sandwich, the traditional sandwich of, like, greening out everything that is not a sandwich crust. And I'll use pink for crusts. Ah. Right, I hadn't noticed this 33. So the outie sum to 2, and you can't do that in 2 distinct digits. So this column, there's a 1 and 2 at its top. Okay, 22. That has to be all of these, because you can't make it in 2 cells with a 9 here. So that is 9. Okay, so one of these is 9. So one of these is 3. Big takeaway is the... Hey, there's room for easy puzzle. Oh, but this can't be 1 or 9. Yeah, I've got all the greens in this box, so this is not 3. Hey, Skojo. So this is 3. Okay, so this is a 1-9 pair. Oh, these were already ruled out by that. Right. Alright. Let's see. Right. Okay, I've used this clue and this clue to their full extent. I'm gonna use the pen tool to mark it. Oh, and this is 22 minus 15, which is 7. Now this is 7, and it doesn't have 1, 5, or 9. Okay, so 2, 6. Or, oh, and it's not 3, 5. So this is 2, 6. Leaving 3, 4, and 8 down here. Oh, this 6 clue, this definitely cannot be a crust, so there's a crust. Okay, so we got 1 and 9 there. That is a 2, 3 pair resolved by this, which in turn resolves this. Yeah, I like that too. Okay. This I've used. Oh, this was also resolved by this. I've also got. Oh, this 4, 5 pair rules 8 out of here. Rules 4 out of here. Sorry, forcing it to be 8. Okay, and. Okay, I can't make 1, 2, 4, 9. Right. Okay, so this is... Okay, right. No, 1, 9, and that's 6. This C is both 1 and 9. Oh, this column. That is 7, making that 3, which makes that 4 and 3. That is 9, that is 1. Oh, what's left down here? 2 and 7. Resolved. There's 2 out of there. That leaves 6 and 8. Resolved. What's left in this column now? Oh, 4 and 5. Don't think that's resolved. Oh, but it does give me a 4, 5 pair here, which makes that a naked single 6. All right. This... Oh yeah, it's buried in the settings. Where is here it is. Killer calculator. Yeah, it's in the advanced settings. Now here is... This is 4, 5... Oh. 4, 5, 7, 8. Well, this is not 7 or 8. It's 4 or 5. Oh, 7 and 8 in this row can only go here. Oh, this is also not a crust, because it sees 1 and 9. There's a 7 up here. It's only 4, 5, or 8 by the column and the row. Oh, but these have to sum to 10. No, these have to sum to 12. So this is 4, 8, or 7. Oh, God, where does 9 go in this box? Goes there. Okay, well, I know there's at least 2 digits in the sum, so none of those are... Aha! Okay, that's the last sound. Now these have to sum to... Okay, these are 7, 8. That is 8, that is 7. Now this is either 2, 5, or 3, 4. Do I know which? Oh, but there's no 1 in here. So this is a 2, 3 pair, and that's 4. Alright, so this is 3, 5, and this is 2 or 4. Because these now have to sum to 7. Where should I look next? Oh. This is 5, 8, and this is 3, 5, 8. Wait, 2 in this row can only go here, so that's not 2, that's 4, that's 3, that is 5, and that is 7 now. 2, 3, 5, 6. This is 2, 3, 5. Oh, these are... Two and 6. Oh, also these are... Right, okay. So we got 2, 6 here. Aha, resolved. Now, this can't be 9, otherwise this would have to be 0. So this is 8, and that is 4. It's 5, 8. Okay, from here should just be... Oh, there's also this. We've got this down to 2 and 5, right? And this to 3 and 6. It has a 2 or a 5, so it's not... Oh, so it's not this. Oh, hey, Damo! Ah, 2 in this box. Leaving 4 and 5, resolved by that. Ah, 4 in this box. Okay, now these sum to 11. So this is either 6 or 9, and nice, and it is not 9. Oh, thank you for the follow, Damo. Welcome. Yeah, I've had that happen before. 3, 7, 8. Oh, that's 8. That is 7. That is 3. And that just leaves 5, 7, and 8 here. That is 7, 8, 5, 8, and 7. Nice. Yeah. Another really good debut. Thank you for the GGs. Yeah, I like that one too. It was approachable without being trivial. And yeah, I like it had a very cool theme too. Huh. Moonwalk. That could be a fun bonus, yeah. Yeah, that could be a fun bonus challenge. I might try that, actually. Alright. Alright, next up is Demano's new puzzle. Let me ping Demano. Orb 3. I know, it's this one. I remember the orb puzzles. Oh. Yes, I should post it here as well. Yes, there. Alright. Neat. Okay. Yeah. Yes. Top row has... Oh, yes, it does. Okay. Yeah, this is an ambiguity. Okay. Standard Sudoku. Place the digits 1 to 9 once each in every row, column, and box. And there are clues outside the grid. Each side, meaning the top, each side contains either all sandwich clues or all X-sum clues. So these clues on the top are either all sandwich or X-sum. So are these. So are these. Okay, and in an X-sum... Okay, and if this is X-sum, these are just here to troll us. And if this side is X-sum, this is just here to troll me. which side contains which type of clue is to be determined by the solver. So if it's sandwich, then the 1 and 9 form the crust of a sandwich, and the clue outside is the sum of the digits in between them. And in an X sum, it gives the sum of the first X cells that are seen in the row or column from the clue, where X is the first seen cell. So a clue of 8 could be satisfied by 2, 6, or 3, 1, 4, or 3, 4, 1. Oh yeah, this is forced to be X sum. All right. Okay, so we got, yeah. So, you can't have a 0 X sum clue, so top row is sandwich, and a 0 and a non-zero opposite each other, well, they can't both be sandwich, so this is X sum. Okay. So, this is 2, 3, or 4. 32. What is the range of X sums? I believe this is 5, 6, or 7. Because it can't be 8, because I can't put 13 here. And it can't be 4, because even if I make these 7, 8, 9, that's still only 28. So I think 5 is the... And 5 would be cutting it kind of close. But it would technically work. Alright. Now if this is 2, this is 8. Also, neither of these are 1 or 9. That's... There's also the fact that 1 and 9 go next to each other in each of these columns. That is pretty restrictive, because, like... if these are a 1-9 pair, doesn't one of these dominoes have to be 1-9 as well? Because I can't do it that way, because then I can't put 1 and 9 next to each other in this column. So if these are both crusts, there needs to be another domino along here that's both crust. And presumably the X sum clues along one of these sides will fend it. Oh, there's also... What is the... Okay, 23, it has to be... The sandwich has to be 4 cells or more. So this is always in the sandwich. Now, these can't both be sandwich clues, because you can only have one sandwich clue in the column. Okay. So at least one of these is X sum. Why did I say this isn't... Wait, why did I color this green? I think that was just a mistake. Alright, if this is 2, this is 8. If this is 3, these are 1, 4... no, these are 1, 6, or 2, 5. If this is 4, this is 1, 2, 3. Let's see. If these are all X sums, do they have to be pretty high? 25, that's at least 4. 19, that could be done in 3 with 3, 7, 9. If it's X sum, though, this is from 3, 4, 5. I don't think any of these can be 8. Oh. Wait, no, these can't all be X sums, because then these... Right, these can't all be X sums because then don't these have to be from 3, 4, 5, 6, 7, and that's too many 3, 4, 5, 6, 7s in here? Yeah. I don't even need to work out what the max is for each of these clues individually. I just know that's too... Okay, I'll use green for X... Well, maybe I'll use green for sandwiches and red for X sums. So these have to be sandwich. Right, and these, any sandwich clue higher than 21 is at least 4 cells, so it has, this at the... Okay, I think what this is telling me is that the the crusts go either here or here. So either this is a 1-9 pair, or this is a 1-9 pair. And meanwhile, these are X... oh, these could be sandwiches, or they could also be X sums, because I don't think... Yeah, this could be anything if these are X sums, so these would all have to be from 3, 4, 5, 6, or 7. Some of them would have to be fairly low, but... Oh god, right. Once these are sandwiches, these have to be X, right. I had that backwards. Alright, and as I figured, at least one of these, one of these greater than 0 clues is just here to troll. Okay, so these are X sums. Let's see. I believe 3 or 4. Is the only possibility for 12. And 3, 4, 5 here. In fact, I can green these, right? Because 24... 4, 5, 6. It can't be 7 because the minute could be is 28. I believe this is also only from 4, 5, 6. Yeah. GG clue types, yeah. This cannot be green. This cannot be... Oh, hey, Demano! This cannot be a sandwich crust, and neither can this. So this has to be one of the sandwich crusts in this. Okay. Right, so that's at least a 4-cell sum. And at most... And at most a 5-cell? Wait, if it's 6... No, if it's 6... No, if I make it 6 cells... Right, then the minimum is 2, 3, 4, 5, 6, 7. That's 27. Right, okay. So, So the outies are at least 2 cells. I should think about the outies, because the outies have to be 12. There has to be 12... Oh, no, 11. The outies have to be 11. Okay. Oh, and this can't be crust, because one of these would also have to be crust, and that doesn't work. Right. Because these are green. Alright. And so there's a crust up here, right here. So there is a crust in this domino somewhere. And it also is going to be at least 4 cells. So that's... So that greens out these. And down here, I believe that does the same thing. Alright. Alright. Can I do more with... Oh, this is a 3, 4, 5, 6 quad. So one of these is 6, one of these is 3. If this is 6, this is 1, 2, 3, then this is 7, 8, 9. So there'd be a 9 in here. It would have to be here with a 1 here. Seven, 8... 4, oh, the max I can make it is 4, 5, which is 24, so that is enough. That doesn't break this. Okay. Let's see, where does... Right, one of these... This is a 1, 9 pair, this is a 1, 9 pair. Now, if it's here, then this is crust, then this is crust. Then this is crust. Then this has to be crust. Then that's crust. Then that's crust. One of those is crust. Huh. Okay. What does... Oh. Well, there's also, what's left in this row and column. This is 2, 7, and 8. Most of those... Yeah. Yeah, and, hey, Screaming Ice Cube. Yeah, these, green is sandwich and red is X sum. Does there have to be a crust in here? I think there could still be these as crusts. Because if there had to be a crust here, I could green out these, and this, for that matter. Well, no, I couldn't green out this, necessarily. So either these sum to 11, or all of these sum to 11. If all of those sum to 11, I think that's... It's either 2, 3, 6 or 2, 4, 5. Now, if this is 4, then there's a 1 in here, with the other digits being 2 and 5. Wait, this can't be crust. This, however, this, oh, this, yes, this, in fact, this has to be, oh, God. Okay, and this can't be, right, yes, for the reasons gone over, alright. That's... Okay. So now, these sum to 13. Row 2, column 7, or... Yeah. Oh. If this is 3, 9 goes with another 3. If this is 4, 9... Oh, right, yeah, there can't be a 9 in here. There has to be a 1 here, so there's a 9 out here. Okay. 9 here. That goes very well with this. So what about the fact that these are 13? Okay, I don't think this can be 4 in that case. Because this would have to be 8. Okay, 13. And these or these have to sum to 8. Okay, so that's 1. That's 9, 1, 9, 1. Oh, and yeah, that's also 9. Okay, so these sum to 11. Without using a 1, that's 2, 3, 6, or 2, 4, 5. Okay. So if this is a 5, this is a 7. And if this is a 6, this is 2, 5, or 3, 4. Okay. I guess if this is 5, 1, 7, doesn't this have to be 2, 6? Because it can't, because it needs to sum to 8, and it can't be. Would also venture that neither of row 8, column 7, and column 8 can be 9. Oh yeah, for the same reason, right. 1's here, 9's there. So if this is a 3, this is 1, 8. And if this is 4, this is 1, 2, 3. Oh dear. If this is 5, this is 2. Okay, so there's a 6 in here. The corner marks in this column are gonna confuse me. Oh, neat. Gotta try that at some point. Oh, I haven't looked at these in a while. This is not 4 now. And this, okay, this is 10. Like, if this is 5... Yeah, there's no way this is 5, because this would push it too low. So this is 6 or 7. So either these sum to 13 or these sum to 13. If row 9, column 1, x sum is... Oh, yes. Exactly. Oh, this can't be 3. Because there's no way for these to sum to 12 if one of them is a 1. So this is the only place for 3 in this column. So this is 1, 8. Now, if this is 8, this is 1. Can I make 25 in 4 cells without 8 or 9? No, the max that could be is 22. So this is 1, this is 8. And I know the 9 goes in one of these. Oh, that's 1 right there. Ah, and I know this is at least 4 cells, so that is 9. And similarly, the 1 goes here, that's 9. So there's 22. These sum to 13. Ah, but these sum to 10. So these sum to 7, and they're not 1, 6, or 3, 4. I think this is a 2, 5 pair, right? Yeah. Leaving 4, 6, and 7 to finish off the row. Nice. Oh, this being a 3 now would make these sum to 7. This would be 6, 1. I think that works. Oh, but this can't be an 8, so this isn't a 2, so this is, in fact, 3. Okay, and this is 6, 1. Okay, so that's 1. Okay, and that's... Okay, that's 9. So this is 3 cells. Making all the intended deductions. Neat! Which, oh, oops. Okay, what's left in this box? 2, 5, 8, 9. So this is... Oh, well, this can't be a 9, or higher than 9, so this can't have a 2 in it. This is 5, 8, that's 13, that is 6. Okay, and this is 2, 9, specifically. Oh, and I believe I mentioned earlier that this... Yeah. Oh, that also resolves these. Alright. What's left down here? 4 and 5. Okay. Oh, that's 6. Okay. So these sum to 32. What I've got here is 16. So these also sum to 16. The max I can make these is... Wait, can either of these be 2? No, because then the max I can make this is 7. This would need to be a 9 or higher, so neither of these is 2. This is, in fact, 5. And this is... here. Oh, there's the 2 here. Okay. Oh, these sum to 9. So that's 5 or 6. Also, these sum to 11. 12. Yeah, that's 21. I need 11. Okay, so this is 7 or 8, and it is not 8. It is 7. So this is 4, and this is 5. All right. Oh, this is a naked single 8. 3 and 4 there. This is 2, 3, 8. That's not 8. Oh, where does 1 go in this box? We got little X-wing to finish off 9s. I don't think that's resolvable just from the outside clues. But this... Okay, these sum to 13. So this can't be 8, because these can't sum to 5 without using a 1. So that is 8. And these sum to either 9 or 10. I guess that's just 4, 5, 6. Okay. Let's see. I'm going to start un-Xing ones where I've used all the where I've gotten all the information I can. Alright. Oh yes, okay. Yes. Okay. Now, these sum to 12. That's 4, 8, or 5, 7. Okay, that creates a 4. Okay, so either this is 4 and this is 8, or this is a 5, 7 pair. Because it can't be 3, 9 without the 3. And so that creates a 4, 5, 7, 8 quad. So this is 2, 3, 6. So these also sum to 12, basically. Alright. Let's look at this. This can't be 5, because this would have to be higher. Right, okay, so this is 4. Right, okay. And these now sum to 10. So, wait. I think I broke something. Does this need to be 5 or 6? Good question. Don't these need to sum to... Oh, these sum to 10 or 11, not to 9 or 10. Okay. Okay, so, but I think everything else, I didn't rely on that to get any of these deductions, so I think this is still true, that this can't be 5 now. Right, so these need to sum to 11. No, these need to sum to 10. And these need to sum to 11. Wait, if these sum to 10 or 11, These can't sum to 11. These sum to 11. So in fact, this is 7, this is 3. Oh, that was cool. Okay, that is not 7, so that is not 5. Okay, that X sum is done. And what's left up here is... Ow, ow, ow. Yeah, I was reaching down, I hooked my headphone cord on something, and it tilted my... Alright, what's left here is 5, 6, 8... Oh, where does 6 go in this row? So that's a 5, 8 pair. What's left in this box? 4, 5, 7. That's not 5. Alright. These also sum to 13. So there's a 6 with 2 cells that sum to 7. So if this is 6, this is 5, this would be 2. If this is 6, this could be 2, 5, or 3, 4. Yes, this is always from 2, 3, 4, 5. Oh. This is only from 3, 7. Oh, this. Alright, okay. If this is 6, then these sum to 21. Oh, but the max these can sum to is 20. Right, because if this is 5, 7... Right, okay, so this is 5. Okay. This is a 7, 8 pair now, and it's resolved by this. Okay, that gets... Oh, this has to be a 2 now, right? To make these sum to 21. Yeah. Alright. That's done, and that is done. Now we can just finish off with... finish off this with 3 and... Oh, 6! That makes that a 2. And a 3. And a 6. This is 2, 3, 5. Oh, that's not 3. Why isn't it 3? Where's it? Oh, God, there's a 3 here. Right, so this isn't 3. This isn't 4. This is 2, 5. Okay, so 4 in this row only goes here. Alright. 5, 7, 8. This is 3 or 8. Oh. This is a naked single. This is 7. So that is 4. Okay, so that's 8. That's 5. That's 8. That's 5, 7. This is, I believe the, yeah, I think it's all done now. Alright, now let us What's left here? 6 and 9. Nice. Is that resolved? Okay. 4 and 7 resolved. And that's going to resolve this, which resolves this. Okay. What is this? This is 3 and 6. And that is resolved by this. And that, in turn, is going to resolve this. Let me finish off the coloring before I get the last digit. That's 2. Alright. That was neat. I like how... I really liked the fact that these couldn't sum to 10 because these summed to 10. Yeah, that was neat. Thank you for the GGs. Oh, no problem. Thank you for making it. I imagine most people here have heard of, are familiar with Demono's Adventure Hunts, but if you're not, go check those out. Alright. That's neat. Alright. I will ping Marty. Oh, it eats links. Yeah. I'll put the link in chat. There. Alright. Right. Now to... Okay, this was for one of Skojo's Setting Saturday prompts. The prompt to make something a bit crazy. Okay. For each 4x4 quadrant of the grid, I choose 4 of the digits from 0 to 9 and treat that like a 2x2 Sudoku. Treat that like a 4x4 Sudoku. Ah. Yes. And in the overall 8x8 grid, no digit can repeat in any row or column. Then we got Renbon. This contains a non-repeating set of consecutive digits, which can appear in any order on the line. So it could be the digits 1 through 6, 2 through 7, or 0 through 5, in any order. Region sum. So these must have the same sum as this, and they must sum to this. This has the same sum as this, which has the same sum as this. Oh, but these are in different quadrants, so they must be different digits. Not necessarily. Oh, no, yeah, because any digit Okay, well, let me finish reading the rules first before I start making deductions. Adjacent digits along a green line have a difference of at least 5. So these must differ by at least 5, so must these, so must these, so must these, and so on and so forth. And Nabner, no two digits anywhere on a yellow line may be consecutive or the same. So if I put, say, a 3 here, I then can't put another 3 or a 2 or a 4 anywhere else on this line. Okay, that's all the rules. Right. I know these... I know any quadrants, any of the 4 quadrants that share an edge, any 2 of them have 0 digits in common, because otherwise you get repeats in columns of the final puzzle. So, there must be... whatever sum this is... there must be, not only must there be 2 separate ways of making it, but they can't have any digits in common. Oh, but if you add 0, that gets a bit less restrictive. Oh, hey, Marty. Now, this must be 6 consecutive digits. Now... well, okay, an easy one is where does this digit go in this box? It can only go there. And it has to go here. Okay, so it goes on this line. So it goes on the Renbon here. Wait, oh, that's not true, because this could be... because this could be 0. Then these would be the same. I guess this would also have to be 0. Ooh, that's... yeah, that's tricky. Alright, okay, German whispers work a bit differently with 0 to 9. Because I can actually put a 5 on a German whisper now. Oh, except I still don't think I can. Oh, yeah, a 5 here could go next to 2 zeros here. But I can still do modified polarity coloring. If I split the digits to 5 or lower and 6 or higher, I think I can still do polarity coloring on here, because don't they still have to alternate? No, it's 4 or lower and 5 or higher. Yeah, because a 4 can still only go next to 9s, 5 can still only go next to 0. Right, so these do have to alternate. I'll use red and what's... I use red and green for the placeholder colors. Okay, so this digit and this digit are the same, because where does this go in this box? And this digit is the same. Okay, so this... so I know that these are the same. And now this goes here. Oh, this goes up here. Okay, so this has 1 red and 3 greens, whichever polarity. Okay, and these cannot be the same or consecutive. Well, they already couldn't be the same because they were in this. But these can't be consecutive, and these are the same as these. And like this and this are the same. This goes here. This digit goes on the number along with. So these and this are the same. What does that mean for? And I know this isn't. Well, these have to be different. So like this cannot be 4 or 5. So it can't be on the edge of the border between the polarities. Oh, okay, so these two are the same digit. Whatever digit this is, it cannot go anywhere in this quadrant or this quadrant. Now, I don't think I can fully resolve. I mean, I know this goes here, but I still got here. Oh, these two and these two are the same. So in fact, this can't even. Not only can it not be 4 or 5, I think it also can't be 3 or 6, right? Because 3 can only go next to 8, 9, and 6 can only go next to 1 or 2. Oh, these are not the same digit as that. So these have to have a difference of at least 1, of at least 2. So if this is 2, this is 7, 9. And no, 6 can only go next to 0 and 1, right? But that's still, right, this still can't be 6. And if this is 7, this is 0 and 2. Oh, and this digit, which goes here, these are 2 separate digits. So this also cannot be 4 or 5. But wait. Oh no, right. If this is 2, this is 7, 9. If this is 7, this is 0, 2. So that doesn't... Right. I don't know if I can take that any further. Now, okay. whichever 4 digits I put here, it takes 4 out of the 10 possibilities here. So these, okay, wait. These have to have at least 2 digits in common, right? So in fact, I can only have 6 distinct digits here. Oh, okay. And does it have to be the middle 6? Well, it has to have... Well, this does have to have 4 and 5 on it. Doesn't this also need 3 and 6? Because this can't have a 0 or 9 on it. Yeah, so it needs a 3 and 6 on it. Wait, doesn't that mean that these 4 digits and these 4 digits have to be exactly the same? Because none of these digits can go in here, and none of these digits can go in here, and they are 6 distinct digits. Right, yeah, these and these are the same. Okay, so there's 4... Okay, can I narrow down which is which? I believe the red digit in here has to go on this. Oh, well, wait. No, this is... If every other digit goes on this Nabner, this is 0 or 9. And one of these 3 digits goes here, one of these 3 digits goes here, right? So this is... Right, the boundaries are 4, 5... Right, so this digit does have to go on here, somewhere. I think... Wait. Is it possible that none of these are red? Is it possible that these are all green? No. Because... Right, because... one of these digits would have to go down here, but this would have to go... Right, yeah, okay, so this is green. I think one of these has to be red. So this is either 1, 2, 3, 4, 5, 6, or 3, 4, 5, 6, 7, 8, right? So this is either 1 through 6 or 3 through 8. Okay, if this is red, this is red. And it's something to do with these, because this is 9. What do I do? There's the fact that this is a... Oh. Well, this digit, it has to go on the Renbon at some point. And it can't go in here because it's not... Wait, couldn't this still go on here and here? Or is there some reason why that wouldn't work? That would force these to be this. What is... what do I... Right. 4 of these need to be red. And the greens are either a 3-4 pair if green is low, or a 5-6 pair if green is high. If this is different from this, it goes here, and this goes here. Do I know more about, because like, from here. I feel, what is... I kind of want to just guess a polarity and then fill in the rest of these and see what else I can get and see if that breaks, but there's probably something else I can do, but the question is what? Oh. Both 0 and 9 have to go in here, don't they? Because this is either... Oh, right, of course. This is either 0, 1, 2 or 7, 8, 9. So this is 1 or 8. So there's no 0 here. So this does in fact go here. On this thing, and it's a minimum of 3 and a maximum of 8. Okay, so there's no 0 in here. Oh. Well, I can just color code each of these. Right, okay. This digit must go here. Oh, I should use a different... Maybe I should use letters. This goes here. So this, okay, this, right, and this is C, so that's C. And this goes here. Right, so that pushes it here. Oh, right, every other red except this goes on here anyway, so I already knew. Okay, this is B. Okay, now I know that one of these does go in here somewhere. In fact, I also know that C goes up here somewhere. C is in one of these. if I make these... Oh, okay. So I know that A is the sum of B and C. So A is at least 3. And then there's, okay, this is C, E, and F. Can I narrow down anything about which is which? Like, if red is high, then this is at least 5, but this... Oh, I also know that there's only 2 greens on here. Do I know that one of them is here? Or could these all be... No. Right. This cannot be the sum of 2 digits of the same polarity. Oh, unless it's green, unless it's low and this is like 4 or something. Well, I know these can't all be high. Can they all be low? This would probably be... without 0, can they all be low? Well, they would be 1, 2, 3, 4. This would be either 3 or 4. This would be 1, 3 or 1, 2. What is... I know the digits in this are C, E, and F, along with A, B, or D. Right, and these are 3 of these. Now, if these are all low, what? If these are all low, well, the max they could be is 9. Okay, so these can't all be the same polarity. Can I get any further than that? What is... Like, okay. If D is high, everything else is low. It's 8 plus... Well, okay. I guess the max this could be is 12. High and 912, I guess that... Wait, no, because... Right, I know there's at least 3 reds. Can there be more? Wait, no, there can't be 3 greens in here. Can there be... Can there be... There's no more than 2 greens in here. And these can't all be the same polarity without breaking this. Okay, so... What... So there's either 1 green or 2 greens in here. Does that mean A is always a high digit? Right, because if these are both low, this has to be high, and if there's a high digit on here, it has to be high. Okay, so A is not 3 or 4. If these are different polarities, then red is low. Okay. Wait, is that? No. No, if these are different polarities, then this is red, which makes it high. Okay. If these are the same polarity... this could still be green if all of these are red. Okay, is there some way I can prove that the two greens on this line have to be in different quadrants? Or can these both be green? If they're green, then they're a 5-6 pair. Or this is... Right, yeah, because... the greens are a 3-4 or a 5-6 pair. What if this is red, though? These could both be green, and this could still be higher. This could still be 7. Okay, is this... Wait. Is this always green in that case? No, I don't. No, because... Huh. Alright, what about here? So if this goes on the Renbon here, it's here. And puts it here. Oh. Wait, if these are both green... Oh, but one of these goes up here anyway, and it doesn't necessarily go on the Renbon. So that doesn't necessarily break this, it just means that whichever of these is green can't go on there, if these are both green. Okay, I guess that does mean 3 reds, so... these would all be red. What if this doesn't go on the Renbon? Then it goes there. these be the same? Greens. Wait. This has to be... These 3 digits have to be these 3, right? But there's nothing they all see, so I can't really... I just... what is... Okay, the red does have to go on here. So... if it's here, then it's there. If it's here, then it's on both of those. If it's here, I guess it could be anywhere. Alright, Okay, if these are both green... These are all red. There are 5, 6 pair. So this is 2 from 7, 8, 9. Then this is at least 15. And this is at most 10. Okay, that doesn't work. Okay, so these can't both be green. What does that mean? Right, so, at least... There's at least one green up here. So... Okay. Can these all be red and C be green? If C is, if red is high, then yes. But what if this is green and red, then green is high. So this would be 5 or 6. Then green is high and that breaks. Okay. Oh, okay, so this is red. And red is high. So this is 1, and these are 0, 2 pairs. It would have been nice if I'd been able to do that when I had actual viewers to see. Oh well. Alright. Alright, so there has to be a green down here. Do I know which one it is? Or can 2 of these be green? Wait, the green, I can't use it. So the only green available is 3 or 4. Those corner marks are just going to be confusing. So it is possible for... Okay. If there's a... If only one of these is green, then this is 8. Then this is a 3, 5 pair. This is 8. What would that be? if these are both green, oh wait, if these are both green, wait, so there's 9 and, wait, so the max this can be is 12. This can be is... Oh, if these are different polarities, that's 14. The minimum this can be is 14. So these are both green. Alright, oh. Alright, yeah, and in fact this is a 3-4 pair. Oh, so this is 7. And this is 10, 11, or 12. Oh, this has to be 5 then, and it has to be 12. Alright. Am I going to disambiguate the 3s and 4s? Huh. Let's see. 3, 4, 6, 8. Alright, I think this has to be... Oh, yeah, because those are the 4 digits up here. 3, 4, 6, and 8. Okay, so this is 6, 8. Oh, so this is 4, 8. Wait, I don't think I do know that 3, 4, 6, and 8 are the... I know that this digit goes up here along with one of these. And I know that there are 6 and 8 somewhere up here. And these are from 3, 4, 6, 8, but I don't know that but I don't know that this digit is the remaining one. These are... Okay, this digit goes in here along with one of these. Oh. But I think there's still only one combo of those that can make... Because I can't put both 5 and 7 up here. So there's still only one way to make 12. Okay. Okay, so there's an 8 down here. Of course, I also can't use this to force 4 on here, because this could be the 4 down here. In which case, this would be just a 3, 4, 6, 8 quad. Okay, what about... Oh, this isn't 5. Oh. Alright. I should think more about... This is 0, 2, 9, right? This either has a 9 on it or it's a 0, 2 pair. I don't think I can... Oh, this needs a 9 on it. Okay. Can this be green? If it is, it's 3. It makes this 8. I don't see a problem with that. Oh, this is also 4 or 8. Wait, this can't be 4. Oh, God. Okay. This is 3. Okay, so it is 3, 4, 6, 8. So this has to go down here. Oh. Okay. Oh, this can't be... Oh, so this can't be one... This has to be 9. Okay, so this is 0, 2, that's 1, 9. Oh, that's 2. Whew. Alright. Thank you for the GGs. Alright, time to ping Isaiah. Alright, and after this, I will start making my own entry for the new prompt. Okay. Normal, so, oh yes, I should put a link to this. Oh, hey, Ambrose. So, normal Sudoku rules apply. So, every row, column, and box, gotta put the digits 1 to 9 once each. Sum difference lines. Each line connecting two circles is a so-called sum or difference line. One of the circled digits indicates the sum of all values along the line. The other digit indicates the difference between the highest and lowest value on the line. Which circle indicates the sum and which indicates the difference has to be determined by the solver. If a circle is bounding multiple lines, it may serve different purposes for those. It can indicate the sum for one and the maximal difference of another one. And doublers. There are 9 doubler cells in the grid, exactly 1 in each row, column, and box, and filled with a complete set of the digits 1 to 9. The value of a doubler cell is twice the digit in the cell. Alright. Well, one of these has to be doubled to get the sum, so I guess each of these sees both of those. Oh, and one of these obviously has to be, in fact, 18. One of these has to be a doubled 9 specifically. Alright, so that's doubled. And in fact, these are all from 1, 2, 3s, and I don't think any of these can be doubled. This is a 2-9 pair, right? Oh, but this can't be the doubled 9, because even if I doubled something on here, which I couldn't do, I couldn't make these sum to... Well, I couldn't double this, so I couldn't make these also sum to 18, or have a difference of 18. Okay, so this can't be the difference, even with a doubled on here. So these must sum to 18. It's not 2. I mean, there's no... This has to be the difference along here, right? I could do something with doubler shenanigans, but... Oh, yes. Alright, 18 and 3 cells without using a doubler or a 9. That's only 2 degrees of freedom. Wait, no, 3 degrees of freedom. This is 5, 6, 7, 4, 6, 8. Or 3, 5, 7. So this is 2, 4, or 5, and it's not 5, so it's 2 or 4. So this is 5, 6, 7, or 4, 6, 8. So there's always a 6. this is 5, so, oh, it's not 5. Okay, so it's 6, 7, or 8. These sum to 12, 14, or 16. Oh. Well, there has to be a doubler on here, right? Oh, not necessarily. Even if this is 8, this could still be 7, 9. So these have a difference of 2. I think this can only be 4, 6, 8, right? There's the fact that this... Oh. Wait, but this has to be the difference on here. Wait, what? Well, this cannot... These have to sum to more than that. So this... Oh, okay. And if these have a difference of 4, I think this has to be doubled. Because I think the minimum this can be is 12. So this is also 6, 7, or 8. Wait. This has to be at least 4, but isn't the maximum difference these could have? Did I break something? How does this... Oh, 5, 9. Yeah, I think that's forced, isn't it? Right, okay. I assume that's the same down here, although... Oh, actually, no, it could be a 4 with a doubled 5. So I think this could still be 6. Oh, but this is 2 now. Okay, so this is 5, 6, 7. It's not 2. Oh, where does 6 go in this box? And that leaves 8 here. That is 7, that's... Oh, 6 and 7 in this column. They can only go down here. Leaving 1, 3, 8. 4. Alright, so I think this has to be either 5, 9, or 4 with a doubled 5. If it's 5, 9, they go there. This is 4, 6, 7. Oh. But wait, if this is 4, where does 4 go in this box? Right, yeah, if this is 4, this is 5, 9, no, I can't put 4 in this box, so this is 6. Okay. The doubled 5, that greens these. Okay, and there's a doubled whatever up here. Okay, so the difference along this line is 6. 2 in box 4. Oh, yeah. Aha. Okay, so there's a 2 on here. So the largest value has to be at least 8. Oh, it has to be at most 8. The largest value is either 8 or 7. Oh, and this can't be... okay. Okay, so there's a 2 on here. Oh, it could be a double 2. Though, if this is... There's a 6 up here. Oh, this is green, so there's a doubled 1, 3, or 4 down here. And yes, I can green those as well. Oh. What about this? Oh, I think this has to be doubled, doesn't it? Because the only way for neither of these to be doubled is if this is a 2-4 pair, which it's not. Okay, so this is a doubled 1 with a 4, I think. Yeah. so this this could still be a lot of things. Okay. All right. Now, if this is there could be a double 2, 3 making this. This could still work as 12. If it's 1, double 2, 3, 4. This would be 3. This would be 1 and 4 with a double 2. Make this 8. And make this 3. That is very restrictive, but I don't think it breaks anything. Okay. How does this work then? Okay, so there's so just by Sudoku, there is a 2 and a 4 down here. What? Is that the only thing that works? If this is 3 and this is 1, double 2, and 4. No, that's not the only thing that works, because even if this is 1, double 2, and 4, this could still be 7, which would... there's a 7 up here. Does that... 7 here, it's not there. This is not 1, 5, 7, or 9. Or 2. Or 3. This is 4, 6, or 8. Now, is there some reason this doesn't work as a 7-9 pair with a 2 difference? This is only 7 or 8 just by Sudoku. This is only 7 or 9 by Sudoku. In fact, there's a 7-9 pair here. What does... Who's... okay, there can't be... There's already a doubled 1. So there can't be... So the double digit down here is 3 or 4. Oh. Is 9 in box 5 off the line? Oh, good question. Yeah, I think it has to be. Yeah, because even if the double... Yeah, okay. Yeah, so there's a 9 here. So the double here are 2, 3, 4, 6, and 8. So one of these has the double 2. Now, 6 and 8 cannot be doubled here, so it's 2 or 4. Okay, so it is 2 or 4 that gets doubled here, or 3, I guess? Yeah, so it's 2, 3, or 4. I believe 8 is also not on the line, but that's... That's a bit less. I guess this digit cannot go in any of these. It has to go here, here, or here. If 1 is on the line in box 5, the line digits must be 1, 2, 4, 7. Couldn't they be 1, 2, 3, a 3 up here with a 1, 2, 4 there, and this being a doubled 6? With a doubled 2 down here? Oh, different 6, right, yes. Right, that is... Yes, I totally forgot about that, even though I... did it earlier. Okay. Okay, so there's no 8 on the line, so... Right, the highest, it has to be 7, doesn't it? Isn't that forced by this? Yeah. With a doubled... with a doubled 2. Oh. I knew it earlier and then forgot about it. Oh, yeah. This is a 1-4 pair. Seven in this row can only go up here. 3, 5, 8, 9. Oh, yeah. This is not 8. Okay, so there's... If there's a doubled... Oh, wait, no, there can't be a doubled 6 on here. Because it would go with another... Because it would go with another 6. And if there's a doubled 4... Oh, a doubled 4 could go with an 8. Yeah. Oh, double 6 would go with 4, right? Okay, so there could be... Okay, so if this isn't... So if there's no doubler here, this is 7, 9, this is 2. If there's a doubler here, doubled 6 goes with 4, makes this 8. A doubled 4 goes with it. Oh. Okay. If there's a doubler on here, it's a doubled 6. And it goes with 4 and makes this 8. I doubt it. Yeah, because if there's no doubler here, right, yeah, this is not doubled. If that's doubled, then that's 2, but if that's doubled, that's not 2 anyway. Oh, lovely. I don't want to hear. Okay. Oh, there could still be a... What if there's a double 3 on here? Oh, then it would have to go with a 10. Okay, so that doesn't work. But of course, there could be a double 3 in here, just in one of these. that's fine. This is 6 or 7. There's no way this is a 7, right? Even with doublers on here. Because, like, if there's a doubler, it has to be a doubled 6. Yeah. So, 7 in this box has to go up here. Wait, but there can't be a set. Okay, so there has to be a doubler. Okay. It's a doubled 6. Okay. This is, okay, this is 4, so this is 3, 1. Yeah, this is 8. That's 7, 8. Four, 1. That's 6, 2, 1. 8, 9. Okay, that's all the lines. So from here, it's just Sudoku. 4 and 9. Not resolved yet. Okay, what about this column? 2, 3, and 9. Oh, 2 in this column only goes here. It's 2. Okay, 3, 9. Leaving 5 and 8. Is that resolved by anything? This is 5, 7. Okay. Oh, this is also only 5 or 8, which resolves that at least. Three, 6, and 9. That's not 3. What about here? 3, 5, and 9. Oh, 3 in this column. And now this is only 5 or 9. What am I doing on 3s? X-wing, okay. 5 and 9. It's not 5. Okay. One, 4, 6, 7. That's 4, 6. That's 4, 7. 7 in column 9. Aha. Ah. This is 3, 6. This is 1. Oh. Okay. Alright, and I'll save this for Thursday. Nice. Alright, now to make the puzzle for the new setting Saturday. Okay, so the prompt for this week's setting Saturday is sandwich and negators. And I mean negators, well, that's a that's a decent excuse to do another balanced Sudoku. Oh, what I need is right wall. And I think I make it a squish doku. That's one puzzle idea that's in my slush pile. Alright. So, I'm gonna see if I can do this. Well, I mean, I know I can do this. So, it's a balanced Sudoku, so you place the digits -4 to 4 in front of column. I'll probably, like... I'm just gonna use Penpa for the testing, for the setting, just for better notation tools, and then we'll see what happens. Then I'll bring it to... And then I'll probably make a version of it in Sudoku Maker, or just to export to Penpa. Though apparently there is a utility to transfer Penpa to Sudoku Pad. Alright, so... Well, I'll type out the basic rules anyway. Oh, I'll check it out then. Are shared between multiple boxes, such that numbers do not repeat in a row or column. Sandwich. Clues outside the grid give the sum of the digits sandwiched between the highest and lowest value in the indicated row or column. Okay. It doesn't show the rules there. Okay. Okay, so, what can I do? Well, I don't want to repeat the break-in for my balanced Quattro Quadri. I want to do something else now. Oh. Well, I can do something similar but not identical. If I make these both 6, 6 is the highest sandwich, and -6 is the lowest sandwich you can have, and it's going to be exactly 3 or 4 cells long, depending on if it includes the 0. Wait, no, I think that's broken. Oh, no, it's not broken. It just means this isn't a crust. in this sandwich. I do think this has to be 0 in that case, because I know that this being 6 means the sandwich is at least 3 cells, so this is always part of it. But it can't be 1, 2, or 3 because that has to be inside the sandwich here. Right, okay, so this has to be 0. And these are part of the sandwich. Okay, so... Oh, I should use numbers just to keep track. Okay, and I will do a somewhat awkward... The reason I'm using Penpa here is to include the signs when doing center marks, which is somewhat awkward, but yeah, it works. Okay, so I know there's a +4 here and a +4 in this column. What else do I know? Wait, if I put... Can I have 2 6s next to each other? Well, okay. Well, I know these are part of the sandwich. Oh, okay. Well... crusts are the highest and lowest value in the row or column. So it's not necessary. So, like, if there's a +4, if there's a +4 in a column, it's always the high crust, and if there's a -4, it's always the low crust. But if there's no, because you don't get every digit in every row and column here. So that should allow me to do the entire thing with outside clues and no other ambiguators. And I don't think it's oh, it's certainly not possible to have... Oh, if I put a 5 here, doesn't that force a lot of things? This forces this to be 1, 2, 3, yeah, and that forces this. Okay, so if I put a 5 here, that might be broken already, but we'll see. Let's see. I believe that forces this, because I can't... Right, yeah, there's no way for this to be a crust. So I can't put 2 of 2, 3 here, because these would have to both be 1. Maybe when I'll export this, okay, but if I put them down here, yeah, I think that's forced. Now the question is, okay, and that just gets me, this is +1. Okay, and this is one of the crusts. Ooh, that's broken. That's still too many. Yes, okay. Okay, what is... Right, okay. What can I do with... What's the highest I can make this? No, that's just postponing the issue. Yeah, I don't think I can... Oh, well, there's the fact that neither of these can go here, so if this is part of the... Maybe if I maximize this and force this to be... Wait. Well, okay. If I force... Could I somehow force this to be in the sandwich? If I make this a 5, doesn't this have to be -1 with like a 2, 3 either here, here, or here? Yeah, that's forced, isn't it? Okay, that would actually get me these here, which is interesting because it means these two are the same as these, and these two are the same as these. I mean, this digit in this box can only go here. For the row 7 clue. Oh, yes. Good point. Oh. Yeah. Okay, maybe... Maybe I should start looking elsewhere. Oh, what happened? Oh, nothing yet. Okay. Okay, well, I could do the obvious thing. If I make one of these like a -5, that would force this to be, if I make this a -5, that would force this to be a +1, there to be -1, 2, and 3 here. Sorry. Oops. Tissues. Ah. Hope I'm not getting a cold. Oh, there are about 7 broken puzzles. Well, when you... I mean, on the one hand, I get it, because you're making people combine combine genres that aren't... Okay, let me see. Let me make this a -5. That does force this to be a 1, and we got... We got -3, 2, 1 here. Okay, so now... Well, that's weird. Huh. Oh. And... Okay, so how do I minimize this now? Like, this can be a minimum of... This is 2, 3. 2... Can these be... Oh yeah, these can't all be... Exactly, yeah. Well, you can't... You actually can force them to be either 3 or 4 apart by making it big, but you can't force them close together by making it small. So, if I... Oh, these could also be zeros. These could also have zeros in them. Oh, but if I make these... If I make this -4... Oh, but then that could just be a simple... Right, yeah, you can't force them all the way apart. Even on a Squish Doku. Yeah, that's... One thing I really like about Balanced Sudoku is how it completely changes both sandwich logic and arrow logic. Now, the thing is, if I make this -4, that could force this to be a +2, with these being 3, 2, 1, 0 quads. But it could also just mean there's a -1 and -3 here, with this being the crust. Oh! Right, and this being a -5 could also just have a -2, 3 here, with one of these as the crust. Okay, maybe I should have... so what is... I guess if I put another 6 up here, that would force... That would at least break the symmetry I've got here, and it would force... necessarily force this to be a crust or to not be a crust. Well, let me try this for a bit and see where we get. Okay, this is plus 1, 2, 3. One of these is a 4 in that case. Okay, and now if I make this... If I make this 5, this is plus 1. Okay, but what would that actually force? It means there's 2... Ah, interestingly... Oh, I see something. If I make this 5... This has to be plus 1, and the 2 and 3 have to go in here. And these 2 cells see all 4 of these. So then, what's the max I can make this? Could I make this another 6? If this is a 0, yeah. I think this is forced? Well, for one thing, it actually gets me my first digit. This is 2 or 3. Okay, and now, if I make this 6... I think this has to be... Ooh, it could go here. With, like, here. Then these would be the same. Oh, but I've still got these to worry about here. So I don't think that works. Wait. Ah, good question. I think... Oh, right. Right, here's one thing I stumbled on when making the Nurimisaki Squish Doku. In a Squish Doku, these two digits can never be the same. Nor can these two or these two. These have to be 4 different digits. Can I use that somehow? Ah, good question. Ah, good point. Yeah, limit on 4s. I think the maximum number of times you can have one digit is 6. I can't remember if there's like a rigorous proof of that, though. In fact, I know this digit has to go here. Wait. These box has to go here. This box has to go here. Yeah, so this digit has to go in one of these boxes. So 2 occurrences of this digit, place it in 6 boxes. So I think this digit, each of these digits appears in the puzzle exactly 4 times. is the fact that these two, the reason these two can never be the same digit, by the way, is in this box it can only go here, and now in this box it can only go here, in this box it can only go here, and now it can never go in this box. So the question is, what does that... Maybe I can go back further and force this to be higher. Wait. Couldn't I make this 5 if this is 0? 3, 1, and these would be 2, 3 pairs.
I'll get you there.
Or does this still break? This would be 1. This would be 0. And now these would be a 4. These would both be 4. These would be a 4 pair. I think 5, 6 here works if it's like this. That would force these to be both low. But not the lowest digits in the column, because those have to be the crusts of this sandwich, of these sandwiches. And now, if I make this a -5, I think that forces this to be a crust. That would force this to be a 3. Oh, well, before I do anything else, that's the other of 2 or 3. That's... because none of these can be 2 or 3. Okay, so I gotta remember there's a 0 up here. A 0 here. And a 0 here. It's more than 4 zeros, so apparently I miscounted earlier. Right. And there's a 4 down here. And a 4 down here. So these are going to be... Oh, wait. These are going to be... These are also going to be... I think this has no value now. Because it sees all the highs in this box and all the lows in its column. And a 0. Oh, dang it. Oh, dang it. That was so cool. Ah, well. Huh. Okay, so what else should I do then? Let's see, what about... Oh, if I just put a -6 here, that would force this to be... Oh. I believe this forces this to be the crust, and this to be +4. Let me see what I can get from that. Okay, this is now +4. These are 1, 2, 3, okay. In fact, and this has to be lower than any other digits, so this is, okay, so this is -3 or -2. But I now have one of the crusts here, so if I... Maybe if I make this 5, well... This cannot be any high digit. It has to be negative or 0. Right, yeah. Right. Oh, yeah. This has to go either here or here. Now, which can I force it to be a specific one? Good thing it's not Anti-Knight. Yes, yes. There haven't been many Anti-Knight Squishdokus, I think, for very similar reasons. Someone's made a few, but I think basically, I think it's so, like, absurdly restrictive that the only real difference is, like, you could just swap digits around, just permute the digits, and it would be, and the layout is basically the same each time. So, one of these must be a crust. And this goes here. All right, so there's no 0 in this sandwich. So the crusts are either here and here, or here and here. So this is either the third from -1, 2, 3, or it's the crust. Now, can I use a sandwich clue, like, up here to force something? This goes here. Like, let's say it's this way. Let's say this is 1, 2, 3. Then this, what can this digit be? This can't be -1, 2, 3. It can only be one of these things. It can only be this digit +4 or this. And in fact, yeah, and it can't be, because, like, if this is the sandwich, there's a -4 in here, so that also rules -4 out of here. So basically, this digit can only be 0 or one of these two. So if I put... Ooh, that wouldn't work. That would create too many... I was about to say if I put a -6 up here, but no, that would create too many minus 1s, 2s, and 3s in here. And if I put a minus 5... Oh, then this could be a plus 3 goes here with a minus 2, 3 here, and a minus 4 down here. Wait, no. Oh, that would put minus 1 here. That would be minus 2, 3, 2. Does that actually work? Wow. Okay. It is very tricky to do this with only outside clues. I am tempted to bring an arrow in, but especially if I, like, place one there, because I know that's not 0. What about this? Like... I also know there's a plus 4 out here. And a plus 4 in this box in here. Oh. Well, if I just make this a plus 3... Wait, if I make this a plus 3, I think the only thing that works is for this to be exactly positive 3. And for there to be a plus 4... Can't have a plus 4 anywhere in row 2. Well, there's one up here. Like, if it's here, okay, that rules it out of here. But that also rules it out of here, so there's one in here. What's wrong with it being here if there's one up here? Would force the row 1 and... Are we sure there is one in row 3, though? Because the crusts here... yeah. But... yeah. That is a very easy mistake to make with balanced sandwiches. I have made that quite a few times when setting these. But I do think that if this is 3... I can't have multiple positive digits in the sandwich, or that creates too many positives in this box or this column. Ooh, could it be down here? No, because then one of these would need to be a 4. Oh, unless this is a 0 and this is a 4. Ooh, yeah, I think that works. For one of these to be 3, this to be a 0, and this to be a 4. Oh. now that this is... but maybe I could do something with this, like... Oh, well, maybe if this... but if there's a 0 down here, I was about to say if there's a -6 here, it forces things, but if there's a 0 in here, this could be down there, and it still have it be. Wait, no. No, if there's a -6 here, this can't go in this direction. Because then neither of these could be part of the sandwich. Could be part of the sandwich unless they're both 0. Okay. There's probably other reasons why this breaks like 5 million steps from now, but for the time being, let us see what we can actually get from this. Okay, and this... Ooh, yeah, that forces... Oh, yeah, I think I covered that earlier. That forces too much in this box. That forces these to be part of it. Okay. Okay, never mind. What if I did -5 up here, though? Because I need at least 2. Right, I think if I put -5 up here, it might actually work. It is very difficult to, like, explain why, though, because, okay, now if it goes this way... Obviously, this can't be -1, 2, or 3. Nor can... None of these can be -1, 2, or 3. So it would be forced to be... Okay, okay. 3, 2, 1. 3, 2, 1. In fact, this is the same as this. And now... Right, if I put 1 here with... Okay, if I put 3, 2, and there's a 3, 2 with a 0 here... Oh, this is -1 in that case. This is -2, -3, -2. Okay, so this is -2, 0 pair. Okay, so this is -3. I think this technically works. Okay, and there's a crust here. -4 plus 1, 2. Oh, and if I put another -5 down here, that forces it this way. With -4 here, making -4 there. The other -4s would be... Oh, I don't think these can be the same digit either. Right, because in both of these boxes needs to go in the same row. Okay, that's not going to work then. Well, there's the fact that -4 in this box, it either goes here or here, so those all see that. So this can never be a -4. Can it be a -3 if I make this -3? This would be -2, 0, 2. This would be -1. Well, actually, wait. Let's see what I've actually got. Oh, wait, where does -1 go in this box now? Shoot, that does not actually work. Okay, never mind. Ooh, this is inconvenient. Yeah, that was really cool, though. Like, okay, this digit in this box does have to go down here. So, like... but only if... Only if it's negative. Maybe if I go the other direction, like could I maximize this? But I already, okay. This can't be 4, because I'd have to put 1 and 3. Or maybe 2 and 3. if I put 4 up here, couldn't I put 2 and 3, a -1 or 0 here with... No, alright, that's what I tried last time. Oh, but then... No, it can't be 5, but it could be 4 if this was like... Well, let me... I've already forgotten like why that breaks, but let me see. It's 2, 3. Oh. Like, I think this would have to be +2, 3. This would be -1 or 0, and there'd be another of 2 or 3 here with a -1 or a 0. This would be +1 in that regard. I'm not even sure this is the only way that works. But the question is... Well, I know one of these is... Okay, and that does actually... I think that actually gets me this. This can't be -4 in that case, because this sandwich would need to be 3 digits. Of course, that only... Of course, even if that's true, even if this actually works, it wouldn't necessarily be humanable, because you'd have to prove that this couldn't be 2, 3 with a -1 here. Well, this couldn't be 1, 3 with a 0 here. Alright, what... Maybe I can do something with this. If I put a 5 here, like one of these is a 2, 3 pair. So this would be the same as that. Well, if I put another 6 here... that would force it this way. Now maybe I could do something with... Okay, that's... Well, maybe I should just bring in an arrow to bridge the gap here. Because, like, if I draw an arrow here, this can't be 0, so this can't be the same. So that would force this to go this way. Maybe I could do something then. Because, like, the fact that this has to go here or here, and this can't be 0, that... Yeah. Yeah, I'll just do this. Okay, what does that get me? Now that I know this cannot be 3, 2, 1, now that I know this has to be... There's a -4 in here. This digit goes down here somewhere in this box. There's also the fact that this... Wait. This can only be... This can't be -4. This has to be 0 or... This has to be greater than 0. So this has to be... This has to be -4. Alright, so this is +1 or 2. No, it's +2 or 3. Right, and there must be a higher digit than that. Oh, this digit in this box can only go here. So there is a... Oh, this is -4. So this can only be +3 or 4. Because it has to be higher than this. Oh, and if I just... I'll say this is... Maybe I can just... I'll just say this is not 0. So this is not +4. Two, okay, so that's -2. That's -3, that's -1. Okay, so that's +3. Oh, that's plus 4. Okay, so there's a plus 4 up here. Oh, and this is plus 3. Okay, and that's plus 4. Minus 4 in central bone. Ooh, yikes. Okay, Okay, this is just broken just from that. Oh, lovely. Ooh, oh boy. Well, maybe I can... Oh. Maybe if I put the arrow here? Yeah, that would, yeah, that would, yeah. Okay, and this has to be bigger than that. Okay, and now I can do the same thing where I, well, maybe I should do more Squishdoku first. Like, where does... Okay, minus 4 in this box goes down here. It puts it up here in this box. So far, no major issues. Okay, so if I put not 0 here, maybe I'll fill in an actual value for that, or maybe I'll just say it's not 0. That would force this to be plus 4. That's 3. That's plus 2. That's minus 2, 3, 1. Okay, there's a... Oh, that's minus 1 or 3. Okay, and there's a plus 4 up here. Minus 2 in this box goes here. If I put another minus... Ooh, yeah. Okay, so I can't resolve that with that. Because, okay, +4, I've got an X-wing on +4, so this is always gonna be 0. Maybe I can, well, okay, if I put not 0 down here, that at least gets me the -4 down here. Because it's not in any of these. And in fact, I know it's down here. Okay. But... this is 0 or less. Okay, there's a -4 here. Oh, if I put -3 up here, I think that forces this. I think that forces these to be +4. Oh, wait. Wait. Right, yeah. Oh, and it's not greater than 0 either. So it's 0. In fact, wait, let me go back this, because another thing I've noticed is the X-wing on 4s, on +4s, that means this is always +3, no matter what I do. So I can resolve all this. I can resolve these without that. So I think I want to. Okay, that's not 3. There's a 3 up here. Okay. Right, right, okay. So this sees all positives and all negatives, so this is always 0. This can only be positive 1, 2, or 4, I believe. So there's a 0 up here. Right, so the 0 in this box is in here, which... Okay, so the 0 in this box can only go here. That's correct, isn't it? Yeah. 0 in this box, it can't go here or here because of these zeros, so it must go there. And this plus that rule it out of there, so in this box it can only go there. Okay, the remaining 2 zeros are here. Oh, this isn't 2. This is only 1 or 3. Wait, is it possible this is 3? I think if I try to do that, we run into the same problem I had before, right? This being 3... Oh, this goes down here. Can I do anything with that? Well, certainly not in this column, because this is always going to be 0. What about... Now that this can't be... Well, this can't be -4, so maybe... Well, let me see. Let me just bifurcate this real quick. If this is 3... This is a 1-2 pair. This would be -4 in that case. This would be -3, 2, 1. This would be -2. It's 1, 2, 4. Okay, what if I make this 2? That's +4. That's 1, 3. Oh yeah, that doesn't work. Oh. Well, here's something simpler. The +2 in this box can only go up here, so this can't be +2. This is only +1 or +4. Wait. What if I make this a +1? And this a +3. That's a 2. That's a 1. These are 1, 3 pairs. That is +4. That's -2. So +1, 3 pair. That's a -1, 3 pair. I'm not seeing a reason why that breaks. +1 in this box goes here. This box goes here. +3 in this box goes here. I think that works. Okay, and what's more, I think that's forced if I say this is 4. Alright. At 2, 3, 4, 1, 4, 2. And these are -3, 1 pair. -4, 3 +2, 4. So these are -4 and +2. And these are -3 and +... Oh. Oh, right, this is 3. But I think this is still forced. Oh, no worries. And this is -3 +4. Very understandable. I have not been terribly speedy today. -3, 1, +1, 3. Oh, this is a +1, 3 pair. This is a -3, 1 pair. Wait, this is forced to be +2 because it sees everything else. Neat. -4, 0, +2. So this is -4, 0, +4. Oh, this is 0. And these are -4 and +4. So basically, these are all forced. These rows can only ever have 0 as a sandwich clue. What about up here? -3, 2, 1, +4. I could resolve it with the columns. Oh. These are a... Oh, this is everything except -1, I believe. And this is -2. Wait. Yeah, because it sees... Oh, no, this doesn't see... Wait. Right, this doesn't see +1. This is either +1 or -1. And this is either -1 or +2. So if this Well, okay. If I just say this is... If I just say this is less than 6, that would force this. Which would place +2 in this box. This is either -2 or -1. Oh, and if I say this is non-zero, then that also resolves this, because I can't put -4 and +4 next to each other in the column, and I believe that yeah, that forces this to be +1. With this as +4. Wait. Wait, hang on. I've got more resolved here, because this this digit has to go in the sandwich. It has to go over here. Right, okay. This is actually forced. Huh? Oh. I'm using the wrong... Okay, good, okay. Right, this is actually forced. Okay. That's actually forced to be -4. And that's forced to be +2. I believe this is either -3 or 0. -3, -4, -3, and 0. Yes, and the R1 crusts. Well, okay, one of these is plus... Oh yeah, this is +4. This is also forced. Alright, so this is -4 or 3. Alright, this is -3, 2, 1. So these two have to be the same digit. Oh, -2 in this box. It goes here. Exactly. Alright, so we got -3, 1 pairs. Aha, that forces this to be a 0. Okay, and now the -3 in this box looks down here and resolves that as being +4. Ah, so we got -4 here, -3 here. Okay, and what's left down here? Oh. It's +1 here. -2 here. Okay, and now if I just... Why not? Yeah, I can just... Honestly, if I just say this is 0... Yeah, if I just say this is 0, doesn't that force this to be +1, this to be -1, and that resolves the whole thing? Yeah. All right. Okay. Well. Well, I'm about to wrap up anyway. All right. So, yeah, I'll call that good. Let's see who's on to raid. Alright, I'll raid Chatty Cathy. Oh. Alright. Alright, I might be back on... Oh. Chatty Cathy's raid settings do not allow... Did I type the name correctly? Huh. Alright. Alright, I'll raid Vil. Okay. I was worried like raids were broken altogether. But okay. I'll be back on... Okay, I'll sleep on this for a bit and then do a test solve, and then I will be back on Thursday with more puzzles. I might do another game stream on Wednesday. We'll see how I'm feeling. And yeah. Thanks for joining me. I will see you around, and bye!